Unit 1.
Linear regression, the relationship between a dependent variable of y and x. In the example, we use the time you take studying compared to SAT scores. So you would enter your data at stat, and then edit, enter all your data, then go to stat, over to calc, 4, and you'd get the equation of 23x plus 349.4. In a quadratic regression, which is a process by which two equations of a parabola best fit is found for a set of data, which is ax squared plus bx plus c. In the example, we use the number, like the year, and the number 8 cases for each year. So you do stat, edit, enter all your data, go over to stat, calc, down to 5, which is quadratic regression, calculate, and you'd get the equation of 345.14 x squared minus 1380896.5 x plus 1381262.473.
Domain and range. Domain is the values that go into a function, or x, and range is the values that come out of a function, or y. And inequality is a relation that holds between two values that are different, like a doesn't equal b. Interval notation is a group of numbers used to describe a certain span along an axis. And our example problem is finding the domain and range. Our domain that we got was negative infinity, and the range is infinity and infinity.
Graphing quadratic functions. So in the example, we use f of x equals negative x squared plus 1. So you'd set up a table of, we use the numbers negative 1, 0, and 1 for x. You'd put them into the equation, and I got, for negative 1, I got 0. When I plugged 0 in, I got 1, and when I plugged 1 in, I got 0. So then you graph it, and then you get a parabola. And that's your quadratic. Graphing linear functions. F of x equals 2x minus 1. So we use the same three numbers for x, negative 1, 0, and 1. When I plugged negative 1 in, I got negative 3. When I plugged 0 in, I got negative 1. And when I plugged in 1, I got 1. So you plot the points, and you get a line, which is the linear function.
Piecewise functions. Piecewise functions is a function defined by multiple subfunctions. Our example problem was graph each function and evaluate the given value. And so the function was this is the function, and we for each function we plotted the points, or made the points in a chart, and then we plotted them. And then when we evaluated f of negative 2, we got 5, because you do 1 minus 2 times negative 2. Applications of piecewise functions. Our problem was a parking garage charges $5 for up to, but not including, 1 hour of parking, $10 up to 2 hours, $15 for up to 3 hours, and so on. Part A was define the piecewise function. Part B was to sketch it, and Part C, how much will a person pay if he has parked in his car for 4.5 hours, and we got $25.